Hi, everybody. Welcome to our notes about forms of energy. So students will be able to describe the different types of energy and give examples. We're going to learn about some different types of energy. First of all, we need to decide or define what energy is. So energy is the ability to do work or to cause change is the definition. The majority of the energy on Earth originates from the sun. If you just talk about like the quantity of energy we get from the sun. But there are many different types of energy, and we're going to be using a strategy called Mr. Sense. So MRCENTS, and all those beginning letters are going to stand for a different type of energy, which we're going to learn about. Before we talk about the different types, I do want to talk about two different also types of energy, or like the two different subsections. It's called potential energy and kinetic energy. So potential energy is stored energy or kinetic energy waiting to happen. And kinetic energy is the energy of motion. So you're going to learn a lot more about this later on in middle school about potential and kinetic energy and more about energy in general. But basically, this diagram shows like when the bicycle's moving, it's energy of motion, it's kinetic energy. When the bicycle is sitting here at the top of the hill and not moving yet, like it's just waiting, this is potential energy. So it's kinetic energy waiting to happen, or it's stored energy. And then when he goes back down the hill, it's moving again. We've got kinetic energy. All right, the first type of energy we're going to talk about is mechanical energy. Mechanical energy is energy in moving objects, or is the energy of motion and or position. So it can be potential or kinetic. But I want you to think about like moving things, moving parts for mechanical energy. Here are some examples. So we just talked about one, bicycling. That is movement, so it is energy of movement. Windmills, those wind turbines are moving, and so that's mechanical energy. If you're doing any kind of work, hammering a nail, whatever, that is mechanical energy. It's energy of movement. The next type is called radiant energy. We've learned a lot about this one already in terms of, we just finished up a unit about convection, and radiation. So radiant energy is very similar to radiation. So it's energy of light. It can also be known as electromagnetic energy. It travels in waves, and it travels in a straight path from one place to another. So what we learned about with radiation before was like, think sunlight, right? So sun is definitely an example of radiant energy. It's energy traveling in waves. It travels in a straight line. We've got other types of energy. We talked about microwaves in the last unit also with radiant or radiation. It's got waves traveling through there to cook your food, but other things too, like your cell phone. The signals that you get on your cell phone are traveling in waves. Same thing with like a remote control, a radio. All those types of energy are traveling through waves that we can't see to the object that we're looking for. So that's some examples of radiant energy, or energy traveling in waves. The next form of energy we talked about a little bit when we were doing physical and chemical change. Chemical energy. Chemical energy is energy that is stored in the bonds of chemicals. It's involved when a chemical reaction takes place, and it's a form of potential energy. So it's not energy maybe yet, but it's the potential for energy. So I want you to think about chemical reactions. So some of these are familiar to us. Food. Well, the food sitting next to us is potential energy. After we eat the food, that's going to provide us kinetic energy, or energy of movement. But the food itself, it might have taken chemical energy to make it in the first place. But when it's just sitting on our desk, it is stored or potential energy. But it's going to undergo a chemical change to give us energy later. Coal by itself, just sitting there, doesn't really do much. But when you burn coal, it produces energy. So the coal itself is potential energy. A battery, wood, same thing. We got to burn the wood to get chemical energy. And then photosynthesis. So we talked about photosynthesis, right? The change is happening, a chemical change is happening in the plant. That photosynthesis is giving us green and oxygen, and all kinds of stuff is happening. So That is examples of chemical energy. The next type of energy is electrical energy. We have not talked about this one. It's the energy of moving electrons or electric charges. So we haven't had electricity for actually all that long in the existence of humans, right? We've had fire and chemical energy way before we had electrical energy. So electricity was really first used in homes in the late 1800s. Of course, now we can't even imagine our lives without electrical energy. Here are some examples. Basically, anything you plug in to get electricity, right? A lamp, anything you charge, your cell phone, your computer. Although then that charge gets stored in a battery, which would be a chemical change, like that battery stores energy chemically. And so because we just had battery, I'm going to go back. A battery in chemicals. So that battery is a chemical change. Something's going on inside that battery to give you power. All right, so back to electricity. We've got to charge that battery with a charger, and it takes electricity to charge it. A refrigerator we plug in, a vacuum. I'm sure you guys can think of some other stuff that's in your washer and dryer, things that are plugged into your home that we use electricity for. All right, the next type of energy is nuclear energy. And we're going to have to go back a little bit. We have talked about nuclear energy before in terms of nuclear fusion down here, but it's the energy locked in the nucleus of an atom. So it's either splitting an atom up or joining an atom together. And it's that atomic level energy that we talked about about stars. So stars take atoms, take hydrogen, fuse it together to make helium, and that produces a ton of energy, that reaction of fusing that atom. Nuclear fission is splitting an atom. So that's what happens when we have nuclear energy on Earth, like a nuclear power plant. We take like a big atom like uranium, which has a lot of protons and electrons, and we split it. And when we split that atom, we get tons of energy. Same thing with an atomic weapon or atomic bomb. We are using fission. We are splitting that atom and creating energy. So that's called nuclear energy. Scientists are working on trying to reproduce nuclear fusion on Earth. Right now, only stars can do it, but we're, I think, getting close in a laboratory, which would be great to be able to do nuclear fusion. So examples, stars, nuclear power plants, atomic bombs. So that's kind of what we just talked about. So the energy is inside the nucleus of the atom. All right, the next one is thermal energy. We just finished talking about thermal energy with conduction, convection, radiation. But thermal energy is the energy of heat. The particles of warmer objects move faster, so the hotter something is, the more thermal energy it has, so the colder, the less thermal energy. Some examples of thermal energy: a fire, an iron, a toaster, a heater, anything that produces heat is going to be an example of thermal energy. Sound energy. The energy of sound is vibrations. So it's the energy from vibrations and matter. The sound can travel through solids, liquids, and gases. And the sound must have matter to travel through. So it's a little bit different than radiation or radiant energy, which is traveling through waves and it can travel through space. Sound has to have something to travel through, which can be air. Some examples: any kind of musical instruments, a bullhorn, radio, singing. You might be thinking that some of these things, like a radio, we just talked about with radiant energy, there might be more than one type of energy in something. So the signals from a radio station to a radio is a radiant form of energy. It's traveling in waves. But the sound that comes out of your car radio after it gets that signal is a different type of energy. It's a different type of vibration energy. So that's what I want to leave you thinking about, is some things can have multiple forms of energy. And I want you to think about what forms of energy are used by a flashlight. Can you think of several forms of energy that are part of what a flashlight needs to work? All right, we'll talk about that in class. All right, some memes. These are kind of about potential and kinetic energy with cats. Potential energy converts to kinetic energy in 3, 2, 1. You can tell that cat is ready to pounce. And then this one about I'm not lazy, I'm just enjoying having potential energy. So I hope you learned a lot about different types of forms of energy today. And as always, science rocks.